Hello everybody, welcome to the video for numbers 16 and 17 on Cumulative Review Packet number 10. These problems are from section 8A.1 if you want to use that as a reference point. So the first two are just asking you about a lot of information about the graphs before we do any graphing or factoring with it. First thing I would always do is check to see if we've given you something in standard form. This first one is not, because this is of higher degree than this. So I would really suggest rewriting the problem otherwise, or checking for the standard form first, otherwise you might get things wrong that you don't mean to. So I wrote it from highest power to lowest, and now that it's in this order, the highest degree that I see is 7. Notice I'm not adding exponents because I do not have more than one variable, it's just the highest exponent. If 7 is the highest degree, the lead coefficient is the number attached to the highest degree. The number of terms separated by a plus or minus sign are 4. The possible number of extrema really means the number of turns that a graph can do, is always the degree minus 1. So it would be 7 minus 1 or 6 possible turns. The possible number of real zeros always matches the degree of the polynomial. The highest degree is always the possible number of zeros, so that would be 7 as well. The Y-intercept is when you find 0, something, which means you plug in 0 every time you see an x. And if you do that, this term becomes 0, this term becomes 0, this one becomes 0, and the only thing that's left is negative 10. So 0, negative 10 is my Y-intercept. And the last and hardest part about this is the end behavior. Now, what I would do is think about what this graph really looks like. And in general, when you're looking at a graph, you really only want to look at the lead coefficient, if that's positive or negative, and what the biggest degree is doing, because this determines what kind of shape we really have. Anytime you have something with an odd degree, it's going to look more like a snake rather than a type of parabola. So I said that this should have about 6 extrema or 6 turns. So my graph is not going to be perfect here. But I know that because my lead coefficient is 4, my graph is going to be rising from left to right, which means if I drew a quick sketch before doing this, it would probably look something like this. It's rising, so it's a snake, probably with a couple bumps in the middle, but it's going to be starting low and ending high. Now, the most basic snake looks something like this. That's if you were dealing with x cubed, but there's a little bit more turns going on because it's x to the 7th. So let's look at this graph to determine the end behavior. As x is going towards infinity, so as x is going this way, it looks like my y values are going up forever. So y's are going to infinity also. However, as my x's are going to the left or towards negative infinity, the graph is dropping. So as I'm going this way, my graph is falling, which means I'm actually going towards negative infinity. So my suggestion for all of these would be drawing a quick sketch based on the lead coefficient. Because it was a positive, I knew the graph was rising, and I knew that the highest power was 7, so I knew it looked a little bit more like a snake. Unlike the next example. First, let's check to see if this is in standard form. It is. So that means everything is going to depend on this first term. All of these matter, but this kind of determines the general end behavior or the general shape of what's going on. The degree is 6. The lead coefficient is negative 9. The number of terms separated by a plus or minus is 1, 2, 3, 4, 5 terms. The number of extrema or turns is the degree minus 1, which would be 5 possible extrema. The number of zeros, again, is always the same as the degree, so that's 6 possible times it crosses the x-axis. The y-intercept, you plug in x equals 0. So if you plug in 0 for all of these terms, everything is going to become 0 except for 3. So the y-intercept is 0, 3. Now let's think about end behavior again. If we look at these two, let's see what's going on. This time I have a lead coefficient that's negative, which means that my graph is going to be falling. I also know, because I have a even power, that my graph is going to look more like a parabola. And the reason it's upside down is because of the negative in front. Now, again, it says that there's 5 possible turns, so my picture is not going to be perfect, but we're going to have a lot more bumps in the road. But my graph, in general, is going to look a little bit more like a parabola or behave more like a parabola and have both arrows going in the same direction, unlike a snake which go in opposite directions. So if we think about this for end behavior, as x goes to infinity, so as I'm going towards the right, my graph is eventually falling. So my y's are going towards negative infinity. As my graph goes towards the left or towards negative infinity, my graph is also falling. So this answer is also negative infinity. And so end behavior is really talking about what is the graph doing as it's going forever to the left and forever to the right. All of this comes together in the last example, number 17. And we're supposed to sketch a graph based on factoring, based on finding the x-intercepts and y-intercepts. And again, we want to consider end behavior, we want to consider terns or extrema, and we want to consider multiplicity of zeros, meaning how many times a zero occurs. And I'll go through all of that. So if I would like to find the x-intercepts first, the x-intercepts, I know that y is 0. So I'm going to start there, because a lot of the times factoring can help me find at least a good place to start. When I look at this factoring problem, I notice that I do have a greatest common factor of x at least. Let's see, can I take a 3 out of all 3 of these numbers? I can. So if I took out a 3x, I'll be left with x to the 4th minus 14x squared, and then 147 divided by 3 is 49. And I took out the x. Okay. So the question is, can I continue to factor this? Well, here's what I notice. X to the 4th and 49 are both perfect squares. So let's see if we can keep factoring this. X squared times x squared is x to the 4th. 7 times 7 is 49. And to combine to be a middle term of negative 14x squared, I could have negative 7x squared and another negative 7x squared, and that would be negative 14 if I FOILed this back out. So here's how it factors. So if I set them all equal to 0, we would have 3x equal to 0, we would have x squared minus 7 equal to 0, and then we would have x squared minus 7 equal to 0 for a second time. So it looks like my x-intercepts are at 0. If I solve this and get x squared equals 7 and take the square root, I have x equals plus or minus root 7. And this is the exact same, so I get the answers of plus or minus root 7 again. Which brings up the idea of multiplicity. This x-intercept, which is really at 0, 0, only had a multiplicity or repeating one time. However, you might notice that the factors were the exact same. So positive root 7 happened twice, and negative root 7 happened twice. So positive and negative root 7 have a multiplicity of 2. And when we have a multiplicity of 2, that means on the graph we're going to see a bounce. And if we have a multiplicity of 1, that means it goes through the x-intercept. So let me kind of think this through. Before I do any graphing, it also asks me to find the y-intercept as well. Now the good thing about this problem, the y-intercept, is when you plug in x equals 0. If you plug in 0, 0, and 0, you're going to get 0 out. So it happens to be that the x-intercept and the y-intercept are the same, but I'll write it here anyway, that the y-intercept is also 0, 0. So that means I know that the graph goes through 0, 0 for sure. And the graph also goes through, if I'm being formal about it, my roots are at 0, 0, root 7, 0, and negative root 7, 0. In decimal form, just to help you approximate, these are 2.65, 0, and negative 2.65, 0. So if I graphed those, we would be a little bit past 2.5 and a little bit past negative 2.5. And so the graph either has to bounce or go through all 3 of these roots. So that's step 1. So we took care of this and we took care of this. So now let's think about end behavior and let's think about terns. So I know that the highest degree is 5, which means this graph has 4 terns or 4 extrema because it's always the degree minus 1. So that'll be helpful. In terms of end behavior, if I look at the beginning of the problem, I have 3x to the 5th. Anything that is an odd exponent always looks more like a snake. And because my lead coefficient is positive, I know that my snake is going to be rising from left to right. which means my graph down here is also going to be rising from left to right. And I know, again, I'll have 4 turns, and we'll check that at the end. So let's just try something out here. If I know that my end behavior starts down because my snake is rising because of a positive lead coefficient, I'm going to start down here. I'm going to go towards the first root that I see, which is negative root 7. Negative root 7 has a multiplicity of 2, which means it's going to bounce at that root. So we're going to hit it, and we're going to bounce back down. The graph then, we know it needs to go through 0, 0. So I'm going to head back that direction, and 0, 0 had a multiplicity of 1, which means we go directly through it. So we're going to go directly through 0, 0. We know we need to go through root 7, 0. It also has a multiplicity of 2, which means we're going to bounce off of this one as well, and then we're going to continue our graph forever up, because our graph has to be ending upwards because I'm going up from left to right. So let's check something else out. Did I have 4 turns? Well, I turned once, twice, 3 times, 4 times. Awesome. Everything seems great. I have 4 turns. It goes through every X-intercept I wanted it to. It bounced where there was a multiplicity of 2. It went through where there was a multiplicity of 1. And it has the end behavior that I expect. So this is a problem that I would definitely consider redoing a couple times. I'm sure there's other example problems that we've done in class 2 that I would redo. There's a lot to think about, but I don't think it's anything you cannot handle. All right, guys, thank you so much for sticking with me. I hope this video was helpful.